So am I audible, guys, now? Okay. Yes? Cool, cool. Great. So let us discuss now. So welcome you all to the post contest discussion of Leetcode Biweekly Contest. So let's start with the discussion now. So this is the first problem. I am audible right now? I am audible now, right? Just give me a thumbs up. Yes, great, great. So the name of the problem is count subarrays of length 3 with a condition. So the problem goes, as you are given an integer array nums, you need to return the number of subarrays of length 3 such that the sum of the first and third numbers equals exactly half of the second number. And here they have given you a definition of the subarray. A subarray is a contiguous non-empty sequence of elements within an array. Okay, so how we can solve this question? So this is a very much brute force question what they have given. So what they have given is they have given you an array of size n, and then they have given you n elements in the array. Now they are asking you that tell me how many subarrays of length exactly 3 are present such that if these are the 3 elements, let's suppose this is A1, this is A2, and this is A3, then A1 plus A3 is exactly equal to A2 by 2. That is the first and the last element. Its summation is exactly equal to the half of the middle element. So I hope the question is clear to every one of you, right? So how we can do this? So what you can do is you can just traverse over all possible subarrays and check that which subarrays satisfy this condition. For every subarray that satisfies the condition, you can just maintain an answer variable, and for every subarray that satisfies the condition, just increment your answer. So how you can do this? So you can start, let's suppose the elements are from index 0, you have index 0, 1, 2, 3, 4 up till n. So you can basically start from index 2 because you know that the first subarray will be this subarray, right? The first subarray of length 3 will be this subarray. Again, the second subarray of length 3 will be this subarray, right? So what you can do is you can start at this particular index. Let's suppose this index is I. You can go up till length, up till index n minus 1. And you can check that if nums of I minus 1 is an even number. See, when I am telling you that the summation of two integers is equal to half of something, so this, since this left part is an integer, so this right part should also be an integer, right? If the right part is an integer, doesn't it mean that A2 is an even number? Right? So what you need to check, if you are at any index I, so that I basically defines the end of the subarray that you are currently considering. So this is the end element, this is the middle element, and element at index I minus 2 is the first element of this 3 size subarray. So what you need to check? You need to check whether the element present at I minus 1th index is an even number or not. And if it is even, then you have to check this condition that summation of elements present at this index and this index is exactly equal to the element present at this index by 2. That is what they have told you to check. If both of the conditions are satisfied, you can simply increment your answer and at the end you can print your answer. So this is what you want to do in this question. So let's quickly see the code as well. So n denotes the size of the array that they have given. I have just initialized my answer to 0 and I go from all the index from index 2 till I lesser than n I plus plus. If I am currently at index I, so as we discussed, the subarray that we are currently talking of is this subarray, that the last element of the subarray is I, the middle element is I minus 1, and the first element is I minus 2. So we need to check whether the middle element is an even number or not. So if nums of I minus 1 is an even number, that is basically modulo 2 gives us 0. And the summation of the first and third element, that is nums of I plus nums of I minus 2, if it is exactly equal to the middle element by 2, then in that case, I am simply incrementing my answer. So at the end, I am simply returning this answer, which is basically what we are required to do. So this is a simple code for this, and the time complexity for this is n, as this loop simply runs for n and you are not doing any extra or other task. So is this problem clear to every one of you? Is this problem clear, guys? Any doubt in this? All clear, guys? Just confirm. Yes, great. So let's move on to the second problem. So again, this second problem was a classical DP problem with a very, what I would say, important trick of bit manipulation as well. Okay, so let's go through the problem. So the name of the problem was count paths with the given XOR value. You are given a 2D integer array grid with size m cross n. You are also given an integer k. Your task is to calculate the number of paths you can take from top left cell, that is 0, 0, to bottom right cell, that is m minus 1, n minus 1, that satisfying the following constraints. You can either move towards the right or down. Formally, if you are at cell I, j, you can either move to I, j plus 1, that is you are moving towards the right, or you can move to the cell I plus 1, j, that is you are moving towards down, if the target cell exists. And the XOR of all the numbers on the path must be equal to k. That is, if you choose some path from 0, 0 to m minus 1, n minus 1, then the XOR of all the numbers that you have traversed in the path should be equal to k. So you have to find that how many such paths exist. And since this number can be very large, you need to return the result modulo 10 power 9 plus 7. So let's understand what actually the problem statement is. So what they have given you is, they have given you m cross n grid. So let's suppose this is the m cross n grid they have given you. And they have given you that every cell has some value. Okay, A1, A2, every cell has some value. Now, if you are at any cell, then you can go either towards the right or towards the down. These are the only options that you have. Okay. Now, you are currently standing over here. And you want to go to this particular cell. So there can be multiple paths, right? You can either go from here to here, then here, then here, and then here. There are multiple paths that you can follow. You can either follow this path as well. You can either follow this path as well. There are multiple paths that you can follow, right? Now, what they have told you, only accepted paths are those. Only accepted paths are those where the XOR of elements in the path is exactly equal to k. So they want you to tell the number of valid paths or the accepted paths are possible. So tell them that how many paths exist from 0, 0 till 0, 0 till this m minus 1, n minus 1. such that XOR of all the elements in the path is exactly equal to k. So is the problem statement clear to each and every one of you? Anyone having doubt in the problem statement, guys? Anyone having doubt in the problem statement? Or is it clear for everyone? No? Okay. So before solving this question, let's first see the constraints given. So the constraints given are that the number of rows in the grid is of the order of 300. Number of columns in the grid is of the order of 300. And the value of k is lesser than 16. And every element in the grid is lesser than 16. So let's see if we can use these constraints to our benefit. So n is of the order of 300. M is of the order of 300, right? Let me just quickly confirm this. Yeah. M is of the order of 300. And every value in the grid, every grid of I of j is lesser than 16 and greater than equals to 0, right? These are the constraints given to us. Okay. So I will just put forward a simple question in front of you that if let's suppose it does not matter to me that what is the value of grid of I of j. Let's suppose it does not matter to me. Let's discuss a very simple DP problem. If I would just not keep this particular condition that a XOR of the elements in the path should be equal to k. Let's suppose I remove this condition for now. Okay. Let's forget this for around 5 minutes. Then tell me how you can solve the question. If I ask you that I am standing at, if I tell you that I am standing at this cell and I want to reach this particular cell, tell me the number of valid paths. If you can either go towards the right or you can go towards the down. These are the only two options you have. Then tell me the number of valid paths exist. If the number of rows are, let's suppose, m, and the number of columns are, let's suppose, n. So there is a very simple one-line solution for this as well. But let us discuss this via a DP. Okay. So a DP solution for this would be that if I just represent dp of I of j, I would just represent dp of I of j as the number of ways to start at 0, 0 and reach I, j. If let's suppose this is the DP state that I am defining, then do you all agree that the value of DP of 0 will be 1? Do you all agree with me in this? Did you all understand what how I have defined a DP state? Where DP of I of j is basically telling me the number of ways to start at 0, 0 and reach the cell with coordinates I, j. This is what DP of I of j telling me. So if I am talking of DP of 0, so I am starting at 0, 0 and I want to end at 0, 0. So I have only one possible way, right? I have only one possible option. So dp of 0 would be 1. Can someone say me what will be dp of I of j? How can we write the transition? If I tell you that I am coming at this particular cell, I wanted the number of ways to reach this particular cell. Don't you all agree that this is nothing but the number of ways to reach this particular cell plus the number of ways to reach this particular cell? Don't you all agree with me in this? That the number of ways to reach this particular cell is nothing but the summation of number of ways to reach this particular cell. Let's suppose the number of ways to reach this particular cell was x and number of ways to reach this particular cell was y. So can I say the total number of ways to reach this particular cell is nothing but x plus y? Yes. This is because I am coming to this particular cell via this cell, the up cell or the left cell. These are the only two options I have, right? Cool. So once you understand this, don't you feel that you will be able to calculate the total number of ways that you can come from 0, 0 till till m minus 1, n minus 1? Would you be able to calculate this? Once you run an entire loop of m cross n, you can simply return dp of m minus 1, n minus 1, which will basically give you the total number of ways to start at 0, 0 and end at m minus 1, n minus 1. So do you guys get this? That if I just simply remove this condition that the final XOR of all the values on the path should be exactly equal to k, then this is how I can solve this problem. Do you guys get this till now? Any doubt till now, guys? Just let me know. Or if it is okay, just give me a thumbs up or something like that. Yes. So now if this thing is clear, how we can actually solve this with this particular condition, that is XOR of the elements. No, 1 plus dp of I minus 1, j minus 1 will not be the case, Rajiv. This is because when you are coming to a particular cell, you are either coming from the top or you are coming from the left, right? So the total number of ways to reach this particular cell is nothing but the summation of number of ways to reach this particular cell and the number of ways to reach this particular cell. Did you get this? Is it okay? Okay, great. So now how we can solve this with this particular condition, that the XOR of the elements in the path should be exactly equal to k. How we can do this? See, if I tell you that I am coming to this particular cell, so I have only two options, right? I will either come through this cell or I will either come through this cell. These are the two options I have, right? These are the only two options that you have. Ujjwal, if you didn't get this, you will surely get this in this one. So just focus over there. So what I am asking you all is, if let's suppose I am coming to this particular cell. So do you all agree that I have only two possible options? I will either come from top or I will either come from left. Do you all agree? Do you all agree? And tell me, what are the possible XOR values of the total number of elements that you covered while reaching over here? What I am telling is, let's suppose this is a grid. Let's suppose this is a grid and you are coming to this particular cell. So there are only two possible ways, right? Either you will come from here or you will come from here. If you have reached till this particular cell, there may be multiple paths that you have followed, right? So if you follow multiple paths, do you agree that you will get multiple XOR values as well? So let's suppose you followed this path, you got some XOR value x1. Let's suppose you followed this path, you got some XOR value x2, and there can be multiple XOR values, right? So tell me one thing. If you are coming to this particular cell from this particular cell or this particular cell, then how many different XOR values possible? How many different, or let's suppose, let me write a new word, how many unique XOR values are possible? Can you guys guess this? How many unique XOR values are possible? It is not 15. It is not 15. No, not NCR as well. It is given to you that grid of R of C, that is every value in the grid, is lesser than equals to 15. So let's discuss this, that how many unique XOR values are possible. If I am talking that every value is lesser than equals to 15, do you all agree that I can represent this grid? I can represent every number of the grid in at most 4 bits. Do you all agree that if every value in the grid is lesser than equals to 15, so every number can be represented in 4 bits? Do you all agree? Yes. If you all agree with me in this, do you all agree that if I just take any number of elements and it does not matter to me what those elements are, and if I do the XOR of these elements, will the XOR value ever exceed 15? What is 15? 15 looks something like this, right? 4 ones when we represent them in 4 bits. For the XOR value to exceed 15, I should have some set bit over here as well, like either the 5th bit, 6th bit, or 7th bit should be a set bit, right? For the XOR value to exceed 15. But it's never possible that the XOR value exceeds 15. Is it possible, guys? Do you all get this, that it's never possible that the XOR value exceeds 15? And the reason is very much clear. This is because leaving this first 4 bits, or if I talk of last 4 bits, there can be no other bits which will be set in any of the numbers. This all bits will be 0. These all bits will be 0. So when I do XOR of these numbers, these bits, leaving this 4 bits, all other bits will be 0. So with the help of these 4 bits, the maximum number that I can construct is 15 when all the bits are 1. And that's the reason if I do XOR of any of these numbers, and it does not matter what the numbers are, XOR value will never exceed 15. So you will have XOR values from 0 to 15. So therefore, there are 16 unique values possible. So now you can easily solve the question by redefining the DP state. You can define the DP state as DP of I of j of s, which tells you number of ways to reach cell I comma j from 0 comma 0 such that XOR of numbers in the path is exactly equal to S. So if you define a DP state something like this, don't you all agree that your final answer, your answer will be DP of m minus 1, n minus 1 of k? Because what does this tells you? This tells you the number of ways to reach from 0 comma 0 till m minus 1, n minus 1, such that the XOR of numbers in the path is exactly equal to k. So did you all understand the DP state that I have defined? Is the DP state clear to everyone that what actually we are doing in this DP state? Yes. If this thing is clear, now you can solve the question very easily as you will solve this particular question. So if you are at a particular cell, let's suppose this particular cell, and you are seeing that in how many ways I can reach to this particular cell, if let's suppose the XOR value is S. So you can just run a for loop for this S from 0 to 15. So you can count the total number of ways to reach this particular cell with XOR value of S. So this is how you can do this. So the total number of ways is the transitioning on the DP is if the upper cell exists. So you can either come from the upper cell, and if the left cell exists, you can come from the left cell. So let's suppose I tell you that if I tell you that I am considering the case when the XOR of values in the path to reach this upper cell is S, and XOR of values to reach this particular left cell is also S. So total number of ways to reach this particular cell, will be nothing but when you reach this particular cell, tell me what will be the XOR value. If let's suppose I tell you that the value at this particular cell, this is I comma j, so the value at this particular cell will be nothing but greed of I of j. So do you all agree that if you have reached the upper cell with XOR value of s, then when you are going to reach this particular cell, your XOR value will be nothing but s XOR greed of I of j. Can I say this? Can I say this? That if you have reached this particular cell with XOR value of S and the value of greed at this particular cell is greed of I of j, then the XOR of the values in the path when you go from this cell to this particular cell will be nothing but S XOR greed of I of j. Hence, I can say that to reach cell I comma j with the XOR value of S XOR greed of I of j, the total number of ways gets incremented by, it's the same way of reaching the cell, this upper cell is nothing but I minus 1 of j with the XOR value of S. Similarly, if you are coming from the left cell, what you can say? To reach I comma j with the XOR value of S XOR greed of I of j will get incremented by reaching the left cell, that is I j minus 1 with XOR value of S. So this will be your transitioning equation. And what will be your base case? Your base case will be if you are at the first cell. So there is only one possible path, that is since you are starting from there. So over there, whatever is the value, that is greed of 0 of 0. So this is only the XOR value of the path. So total number of ways is equal to 1. Total number of ways for being at the first cell is actually equal to 1, right? Because you are starting from the first cell and you are at the first cell. So if you are at the first cell, the only path you have is the first cell only, and the XOR hence becomes the value of the first cell. Yeah, we can go. You don't have to go recursively over the block. You can do it iteratively as well. So what you can do, if you are standing over here, you can just run a loop of I equals to 0, I lesser than m, I plus plus, j equals to 0, j lesser than n, j plus plus, and you can just simply go from like here to here, here to here, and you can just populate these values. Once you are done populating the values, you can simply return that, okay, if you are at m minus 1, n minus 1 with XOR value of k, then how many total ways are there to reach that particular path or that particular block. So let's see the code for this, and then the things will become more clear. So this is the code. So as you can see that the DP that we have declared contains 3 parameters, I, j, and k, right? DP of I, j, and the XOR value, let's suppose k. So this will go maximum up till 299, since it's mentioned that n is lesser than equals to 300, that is the size or the number of rows or number of columns is lesser than equals to 300. So our index will maximum go from 0 till 299, right? So it's safe if we declare the DP like DP 300, 300, and we know the maximum value of the XOR will go up till 15. So we can declare the DP of 300, 316. So for that reason, I have declared DP like this. I have defined LL as long log and defined mod as 1e9 plus 7, since we want to take mod of all the values. So n is, I am telling the number of rows, m as the number of columns, and the base case would be that if you are at the first cell, so that's the only path you have, and the XOR value of the numbers in the path is nothing but the value of the cell, value of the greed at 0, 0. So that becomes equals to 1. Then I am going over all the cells from I equals to 0, I lesser than n, I plus plus, j equals to 0, j lesser than m, j plus plus. If I is 0 and j is also 0, so I am simply continuing because this case is something that we have already handled. Otherwise, we are going over all possible XOR values from 0 till 15. If I is not equal to 0, that is the upper cell exists. Because see guys, it may be that the upper cell does not exist. If you are having the greed something like this and you are at this particular cell, let's suppose, then you can clearly see that the upper cell does not exist, right? So if the value of I is equal to 0, that is the row number that you are currently in is equal to 0. So upper cell does not exist. So the count from the upper cell will not be added. So if I is not equal to 0, then only you are writing this, that dp of I of j of x XOR greed of I of j will get incremented by whatever was the total number of ways to reach I minus 1 of j with XOR value of x. By the same logic, if you are considering that you are coming from the left cell, then you can come from the left cell only when you are not at the 0th column, that is the value of j is not equal to 0. Now again, in that case, dp of I of j of x XOR greed of I of j will get added by dp of I j minus 1 with XOR value of x. Once you're done with this, since you want to take modulo as well, because the numbers can go out of range, so I am just writing dp of I of j of x XOR greed of I of j modulo equals mod, because this is the only thing that we are changing over here. Once you're done with this, so your final subproblem will be dp of n minus 1 m minus 1 of k. So this is what I am returning. And once you do this, you will be good to go. So this was a very, very classic alternation of what I would say this particular problem, that if you are standing at 0, 0 and you can only go right or you can only go down, then what are the total number of ways that you can reach to this end cell? So I would just recommend the ones who don't know this from before, or the ones who don't understand this, first I would recommend writing this particular code by dp and just calculate how many total ways you can reach to this particular end block. And once you're comfortable with this, then you can clearly solve this particular question as well. The only extra thing that this question included was that the XOR value can go maximum up till 15 and it will never exceed 15. If you understand this thing, then the things are pretty much clear after that. So is this okay for everyone? Should I go on to the next code? Should I go on to the next question? Yes? Okay. So this is the next question that we have. So the name of the question is check if greed can be cut into sections. So you are given an integer n representing the dimensions of an n cross n greed with the origin at the bottom left corner of the grid. You are also given a 2D array of coordinates, rectangles, where rectangle of I is in the form start x, start y, end x, end y, representing a rectangle on the grid. Each rectangle is defined as follows. Start x, start y, the bottom left corner of the rectangle is given, and end x, end y, the top right corner of the rectangle is given. Note that the rectangles do not overlap. Your task is to determine if it's possible to make either two horizontal or two vertical cuts on the grid such that each of the three resulting sections formed by the cuts contains at least one rectangle and each rectangle belongs to exactly one section. You need to return true if such cuts can be made, otherwise you need to return false. So let's first of all understand what actually the question is and then we can proceed with the solution. So the question is that you have been given a grid which is starting at the origin, okay? So let's suppose this is the grid that you have. And then inside this grid, you are given some rectangles which don't overlap with each other, okay? So let's suppose these are the rectangles that you are given. So these rectangles will lie entirely inside the grid. So let's suppose these are the rectangles that are given to you, okay? Now what they tell you is it possible to make either two horizontal cuts or two vertical cuts such that when you are making a cut, these cuts don't go from within the rectangle. These cuts don't go from within the rectangle. So let's suppose if you are making a cut something like this in the grid, then this is not a valid cut because this cut goes within this particular rectangle, right? So you can't make this particular cut. This is not a valid cut. Okay. And As you all understand that if we are making two cuts, we will be divided into three sections, right? Section 1, section 2, section 3. So all of these sections should contain at least one rectangle. Is the voice clear now, or is it echoing now as well? Is the voice clear, guys? Just confirm. Or is there an echo? We will see usual. But is my voice clear? Just confirm. Yes? Okay. So is the problem statement clear to each and every one of you what we need to do? If it is possible to make either two horizontal cuts or two vertical cuts, we need to return true. Otherwise, we need to return false. Okay. So how we can do this? So let's first talk of horizontal cuts, and then the same logic can be applied to vertical cuts as well. So I will explain the entire question for horizontal cut. The same logic you can apply for vertical cuts as well. Okay. So let's suppose you have some rectangles. You have the grid with you, and you have the rectangles like this. You have rectangles something like this. Okay. If I tell you what are the coordinates that are given to me, these are the coordinates that are given to me. If this is a rectangle, this coordinate is given, this coordinate is given, this coordinate is given, this coordinate is given, this is given, and this is given, right? These are the coordinates that are given to me, right? Let's suppose this is y1 and this is y2. So can I say that this particular rectangle starts at y1 and ends at y2? Can I say this? That this particular rectangle, this first rectangle, starts at y1 and ends at y2. So just tell me one thing. If I tell you that there is a rectangle from y1 to y2, can you make a horizontal cut at any of these y's such that y is greater than y1 and y is lesser than y2? Can you do so? Did you all understand my question? The question is that if let's suppose there is a rectangle that extends from y1 till y2, then can I draw a horizontal line that bifurcates this y1 and y2? Can I do so? Can I draw a horizontal line like this? Can I do that, guys? Just confirm. Hello. No, we can't do that, right? Yeah. We can't do that. So, because if we do that, it will intersect one of the rectangles and the things will go wrong over there. So do you all agree that if let's suppose I am just only considering the y coordinates for now. So if I have a y coordinate of a rectangle y1 to y2, or let's suppose if I just represent them in number line. If let's suppose this is a number line representing my y coordinates, let's suppose there is a rectangle from this point till this point. Okay. There is a rectangle from this point till this point. Then there is other rectangle from this point till this point. Then do you guys agree? I can't draw a horizontal line at any of these points in between. Do you all agree with me in this? How will this look like? If I just draw the grid of this, how will this look like? So there is a rectangle at this y coordinate. I don't know what the x coordinate is. Let's assume like this. And how will this look like? This will look like let's suppose if you have a rectangle, something like this. Something like this. Okay. It is given that rectangles are not overlapping. So if I just mark down the y coordinates, it will look something like this. You can just assume that I am just taking the y coordinates and marking them in a number line. Okay. There is no overlap. You can see these rectangles are not overlapping. So, but the y coordinates may overlap, as you can see in this particular example. So if I just draw a number line like this of y coordinates, and I tell you that there is a rectangle from this coordinate till this coordinate, and there is other rectangle from this coordinate till this coordinate, then do you guys agree that I can't draw any horizontal line within these y coordinates? Do you guys agree? So if I tell you something like this, that this is the number line and these are the coordinates that I have. A rectangle is from this part till this part. I'm just marking this. There is another rectangle from this part till, let's suppose, this part. Then there is other rectangle from this part till this part. And there is other rectangle from, let's suppose, this part till this part. And there is other rectangle from this part till this part. So do you guys agree that if I draw horizontal lines like this, then I will be able to satisfy all the conditions that every section have at least one rectangle and there is no horizontal line that is cutting any rectangle. Do you guys agree that if the y coordinates look like this, I will be able to do so? So if I just take a random coordinates for this y coordinate, let's suppose I take this as coordinate 1 and this as coordinate 3. This is coordinate 2 and this is coordinate 4. Then this as coordinate 4 and this is coordinate 6. This is coordinate 5, this is coordinate 7. This is coordinate 9 and this is coordinate 10. So if I just simply write down the y coordinates of my rectangle, it will look something like this. 1, 2, 1, 3, then 2, 4, then 4, 6, then 5, 7, then 9, 10. This is how the y coordinates will look like if I just simply arrange them in ascending order. Now just see, just merge the intervals. Just simply merge the intervals. 1, 3 and 2, 4 can be merged, right? Because 3 is greater than 2. So 1, 3 and 2, 4 can be merged. So after merging these two, I will get 1, 4. 1, 4 and 4, 6 can't be merged because this particular segment is ending at 4 and this particular segment is starting at 4. So we are not merging this. So we simply write 4, 6. Now 4, 6 and 5, 7 can be merged. So let's merge them because since the starting point of this particular segment is lesser than the ending point of the earlier segment. So if we merge this, so the segment that we will get is 4, 7. Then this 4, 7 and 9, 10 can't be merged because the starting point is 9, ending point is 7. Hence we can't merge them and hence this particular segment will come like this. So you can clearly see that if after merging the segments, the size of the vector that you are forming is greater than equals to 3, then you can definitely draw a horizontal line such that the line does not cut any segment and any rectangle and every segment has at least one rectangle. So this is how actually you can solve this question. What you can do, you can take the two y coordinates of every rectangle, simply sort them in ascending order and then simply merge the intervals. If after merging, the total number of segments that you are getting is greater than equals to 3, then you can definitely divide these into two horizontal lines or basically into 3 segments such that every segment contains at least one rectangle and drawing a horizontal line does not cut any rectangle. And this is how you can solve this question. So for horizontal line, you took y coordinates. The same thing can be done for vertical lines as well when you take x coordinates. So if you take x coordinates and try to merge, if after that you get a total merge interval length of greater than equals to 3, then you can definitely draw a two vertical lines such that every segment has at least one rectangle and no vertical line cuts a rectangle. Yeah, if you are not able to merge, you're not returning false. Like what I am telling is just merge this. After merging, I formed this particular vector, right? So if the vector form would have been of length lesser than 3, let's suppose. If after merging all the intervals, the vector formed would have been a length created lesser than 3. In that case, I would have returned false, right? I can't draw a horizontal line. So first of all, I will try to see that if I can draw the horizontal line. If not, I will try to see if I can draw the vertical line. If not, then I will simply return false. So there are two possibilities, right? Either I can draw two horizontal lines or two vertical lines. So I will explore both the possibilities, and if none of them is possible, I will simply return false. So this is how actually you can solve this question. So let's see the code as well. So I have constructed two vectors, first for rows and second for columns. So I am just iterating over all the rows. I am just iterating over all the values in this R. And in my rows, I am simply pushing back the values of two rows of basically the two x coordinates of the rectangle given. That is, if let's suppose this is a rectangle given to you. So I am just pushing the x coordinate, this coordinate and this coordinate. I am just pushing these two x coordinates. Similarly, I am doing for columns as well, but in columns, I am simply pushing two y coordinates. Then what I am doing, I am simply shorting this rows and shorting this columns. So first of all, I will try to merge rows. And if after merging rows, let's suppose this merged row vector contains a size greater than equals to 3, then I can definitely draw two vertical lines. So that all the constraints are met. So first of all, I will try to merge rows. So I will just go over all the values in rows or size. So either the merge rows vector is empty, or whatever the current row that we are at, its starting value is greater than equals to the second value of the back value of the merger. So what I'm basically doing, what's the algorithm I'm basically following? Let me discuss that. 1 3 2 4 4 6 1 3 2 4 4 6 5 7 9 10. Let's suppose these are the values that I needed to merge. Okay, so what I will do is, first of all, I will construct a merge vector where that will store the final values, and it is initially empty. Okay, so I will now first of all come to this particular value. I have simply shorted them, and now I will come to this particular value first. So now, first of all, in my merge vector, since my merge vector is empty, I will simply push back this value. So now my merge vector will contain 1, 3. Now I move on to the next value. Next value is 2, 4. You can clearly see that the first value 2 is lesser than the second value of the last element present in merge vector. So definitely these values can be merged, right? So after merging, do you guys agree that the second value will be equal to maximum of whatever this second value is and whatever this second value is, right? So what we will do, we will just update this second value. We will just update the second value. We will just update the second value with the maximum of whatever the second value is and maximum of this second value. So I will just update this to 1, 4. So this second value will be updated. Then I move on to this next. Then I move on to the not only greater than. No, because see, if let's suppose there are two rectangles like this. So it is given that you can definitely draw a vertical line, something like this. So if let's suppose you have two x coordinates same, so you can definitely draw a vertical line like this, and hence these two should be treated in different intervals. Okay. So first of all, you merge this. Now you move on to this value. So this value, the first value, that is 4, is not lesser than this second value. So you will just push back this as a new value in your merge vector. Now you move on to this value. Now its first value is lesser than whatever is the second value for this interval, and hence you will just update this value. The first value will remain the same, and the second value will be maximum of whatever this second value is and whatever this second value is. So maximum is 7, so you will just put on 7 over here. Then you move on over here. Its first value is greater than equals to whatever this value is. So you will just push it as a new pair in your merge interval vector. So at the end, you can clearly see that your merge interval vector contains three values, 1, 4, 4, 7, and 9, 10, and they can't be merged anymore. And hence you have more than or greater than equals to three values, and hence you can easily draw two vertical lines or two horizontal lines. And this is how hence you can solve this question. So this is the algorithm I am following for merging the intervals. So if merge row is either empty or the first value of the current value that I am considering is greater than equals to the second value of the last element in my merge row. In that case, I am just pushing the current value as a new value in my merge row. Else, what I am doing, I am just updating the second value of the last value of merge rows with the max of whatever the value is already present and whatever is the second value of the current item I am at. So this is how I am merging the rows. And if at the end, if the merge rows or size is greater than equals to 3, I am simply returning true. If it is not so, then I am merging the columns by the same logic. And if again if the merge columns or size is greater than equals to 3, I am returning true. And if I am not returned true till now by any of the means, I will simply return false. And this is how actually you can solve this question. This is a very famous algorithm as we call a sweep line algorithm. So you guys can check with that as well. But yeah, even if you don't know that, you can simply merge this via a simple technique as I have discussed. So I hope the solution is clear for each and every problem. So we were only here to discuss the first three problems. So we are done with it. So thank you guys. Any other doubt you guys want to ask or anything, you can just let me know. Got it? Okay. Thank you then. Sweep line algorithm. SWEEP sweep line algorithm. You can go through that. You will be definitely able to solve this. Okay. So good night, everyone. So let's end this stream now.